All right, so in this problem, I have 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And I want to find the most simplified form of this problem. So I actually have 4 answer choices for this problem. So for answer choice A, I have 27 to the power of 30. For answer choice B, I have 9 to the power of 30. For answer choice C, I have 27 to the power of 10. And finally, for answer choice D, I have 3 to the power of 21. So we're going to actually go ahead and check each individual answer choice and see which one uses the right exponential rules to get the correct simplified answer. So let's first start with A, which is 27 to the power of 30. So to get this, what has likely been done is they added all of the bases as well as the exponents. And 9 plus 9 plus 9, that's 27. 10 plus 10 plus 10, that's 30. So that's how they got the answer. And this is actually wrong. That's not the right way to add exponents. Now for B, we have 9 to the power of 30. And to get this, what's likely been done is keeping the base the same as it is. So all the bases are 9, so we keep that the same. And then we add all the exponents. So we do 9 to the power of 10 plus 10 plus 10. And 10 plus 10 plus 10, that's 30, and 9 stays the same. So I have 9 to the power of 30. And this is actually wrong as well. That's also not the right way to add exponents. Now for C, we have 27 to the power of 10. How you get this is you add all the bases and keep the exponent the same. So you do 9 plus 9 plus 9 to the power of 10. We keep the exponent 10 the same. 9 plus 9 plus 9, that's 27. So we have 27 to the power of 10. That's how you got this answer. And that is wrong as well. That's not the right way to add exponents. Finally, we have 3 to the power of 21. And by process of elimination, this is obviously the right answer. But let's see how we actually get this. So we first do 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And now if I factor out 9 to the power of 10, I get 9 to the power of 10 times 1 plus 1 plus 1. Which is equal to 9 to the power of 10 times 3. 9 to the power of 10, that's the same thing as 3 squared to the power of 10 times 3, which is equal to 3 to the power of 20 times 3 to the power of 1, which is equal to 3 to the power of 21. So that is our answer. All right, so in this problem, I have 2 to the power of 3x plus 2 to the power of x is equal to 10. So first off, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 3x, that's going to equal 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 10. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 10. Now if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. And I'm actually going to rewrite y here as 5y minus 4y. Now if I rewrite this in the form y to the power of 3 minus 4y plus 5y minus 10 is equal to 0, I can factor out y, so y times y squared minus 4 plus 5 times y minus 2 is equal to 0. Y squared minus 4, that's the same thing as y plus 2 times y minus 2. I have this times plus 5 times y minus 2 is equal to 0. Now if I factor out y minus 2, I have y minus 2 times y times y plus 2 plus 5. This is all equal to 0, and this is the same thing as y minus 2 times, if I distribute y, I have y squared plus 2y plus 5 is equal to 0. So now this gives me two equations. I have y minus 2 is equal to 0, and I have y squared plus 2y plus 5 is equal to 0. So first off, for y minus 2 equals 0, I obviously get y equals 2. And for y squared plus 2y plus 5 equals 0, if I use the quadratic formula, I get negative 2 plus or minus the square root of 4 minus 4 times 1 times 5 all over 2, which is equal to negative 2 plus or minus the square root of, well, this is 4 minus 20, which is equal to the square root of negative 16, and you can't take the square root of a negative number, so this is wrong. So my only solution for y is 2. Now going back here, remember how we set 2 to the power of x equal to y. So now I have 2 to the power of x equals 2, meaning x is equal to 1. So now to check, let's go ahead and plug this back into our equation here. So I have 2 to the power of 3 times 1 plus 2 to the power of 1 is equal to 10. 2 to the power of 3 is 8 plus 2 is equal to 10, meaning 10 is equal to 10. So this is right. All right, so in this problem, I have x to the power of x is equal to 3. So to solve this, what I'm first going to do is I'm going to take the power of 1 over x on both sides. So I have x to the power of x to the power of 1 over x is equal to 3 to the power of 1 over x. Now x and 1 over x, these two cancel out, so I have x is equal to 3 to the power of 1 over x. Now, if I take the W Lambert function of something in form x times e to the power of x, this is equal to x. So the W Lambert function basically says if I take the W Lambert function of something in the form x times e to the power of x, that's equal to x. So in this case, I'm going to replace x with the W Lambert function. Or actually, before doing that, I'm going to rewrite 3 to the power of 1 over x as e to the power of ln 3 to the power of 1 over x. And e and ln, these two cancel out, so e to the power of ln 3, that's the same thing as 3. And now, this is the same thing as e to the power of ln 3 over x. So now, if I multiply both sides by ln 3 over x, these two cancel out, and I get ln of 3 is equal to e to the power of ln 3 over x times ln 3 over x. And now I can go ahead and take the W Lambert function of this. So I have to take it on both sides. So now this side is simply equal to ln 3 over x. Now, if I multiply both sides by x, these two cancel out, and I get x times W Lambert function of ln 3 is equal to ln 3. And now if I divide both sides by W of ln 3, I get x is equal to ln 3 over W of ln 3. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x is equal to 7 to the power of x plus 2. Now, 7 to the power of x plus 2 can be rewritten as 7 to the power of x times 7 squared. So now we have 3 to the power of x is equal to 7 to the power of x times 7 squared. Now I'm going to divide both sides by 7 to the power of x. So now these two cancel out, and I'm left with 3 over 7 to the power of x is equal to 7 squared, which is 49. Now, if I take the log with base 3 over 7 on both sides, so same thing to this side as well, then these two would cancel out, and for our left-hand side, I would have x, and for the right-hand side, I would have log base 3 over 7, 49. And although this is right, this can actually be simplified, and I could rewrite this as using the base formula for logarithms, x is equal to log 49 over log 3 over 7. Now, log over 3 over 7, well, this can be rewritten as log 3 minus log 7. And for the top, log 49 can be rewritten as log 7 squared. And using the exponent rule of logarithms, I can actually move this exponent to the front of a logarithm, meaning this would be 2 log 7 over log 3 minus log 7. So this is our answer.